So sounds like the previous presenter couldn't make it or something, so I'll be here to entertain you. So bear with me, this is going to be perhaps slightly different. So this is perhaps a slightly more technical talk. So let me tell you something about myself. Yes, okay. So I work at Imperial College, which is not so far from here, just about 4 miles away from here, let's say. For many years, I worked in the industry. I worked for Microsoft Research in Seattle, and I got my PhD from Stanford, and I worked on quite a number of things, but most of them are related to software reliability. So reliability, robustness, as well as security, privacy, all of those topics are mine in a certain sense. You know, the way I pick problems often involves, you know, learning about pain points and learning about industrial practice, which is part of the reason I'm actually here today, to talk to people and connect and understand what the pain points are. And so that's a little bit of background for you. And we have something else on this slide, yes, which is more or less what I covered. Yes, so I mentioned software reliability as well as program analysis. So we build tools for static analysis for finding bugs, as well as software vulnerabilities. We also build runtime tools for preventing issues, monitoring program behavior, doing things like, say, anomaly detection, figuring out how to run programs faster, which is also quite a nice thing to do occasionally, as well as more esoteric things, like, for example, we've had a number of projects focused on crowdsourcing, and I'll mention one of them here because it pertains to issues of testing as well. So that's a very broad overview for you. Next slide. Yes, okay. So let's switch our attention to the topic of testing for a second here. So, well, we have sort of this dual track situation going on. So when it comes to testing, we of course have human effort on the one hand, and then we also have automation. And most of the time, of course, I'll favor automation. I will be in the camp of tool building and figuring out how to eliminate the human from the loop, because that's how, you know, ultimately that's one of the things that is so common in computer science, isn't it, right? I mean, the first things we do as computer scientists is we are like, well, what can we automate here? And I'm also here to argue that that's not always the right thing to do. Much of the time, as we'll see in the next several minutes, having the human in the loop is actually absolutely the right thing to have and to do and to pursue and exploit. So on the left-hand side of this slide, which is over here, we have developer even test suites. That's one of the things that's done quite routinely at different levels, right? So all the way from unit testing to functional testing, what have you. We have field testing these days. It's actually quite a popular thing. I do tend to spend quite a bit of time with, you know, guys from Facebook, for example, and it's quite astonishing, right, what they've done in terms of field testing and automation around that, where they're able to release. Basically, they take a code change, right, a small, you know, patch, what have you. They push it through the system, and it goes out to some number of users. It's not going to be the entire user base of Facebook. It's not going to be, you know, 1 billion people right away. It's going to be a much smaller bucket. But what they do is they instrument those things to figure out if that specific change leads to crashes. They'll look for correlations. And if they detect problems, then they have a way to roll it back. But if it looks good and they monitor it for a while, then, well, this is perhaps something that should become part of the permanent code base. That's a very aggressive form of field testing, isn't it? And actually, well, in a certain sense, why not? If the downside is not so significant, this appears to be a fairly effective way to deploy software, especially on the web, where the consequences are sometimes not so dire. So just keep this in mind when we talk about field testing. Crowd-based testing, I wanted to touch upon that as well, which is, especially because I'm quite fond of this topic and we've built some tools around that over the years. And so nowadays, if you are, I don't know, you're a small company, you build an Android app well, you can have your own in-house testers, right? But you can also hire a company whose job is going to be to install the binary you produce and try to squeeze something out of it, right? Try to create some crashes, try to document those, try to basically put this piece of code through its paces. These days, you can buy those services really quite cheaply, and the response times are low, right? So within, say, an hour, you're able to have dozens of testers working on a piece of software that you just put together. Well, it sounds like a pretty good idea to me, at least in certain settings. Now, I fully realize that in many contexts, this is not something that one can do. If you're developing highly proprietary software that relies on tons of internal data that cannot be released to anybody, well, you're out of luck, unless you can build your own sort of crowd within the organization without violating those privacy boundaries. But in many contexts, it seems to actually work quite well. And of course, one of the things that I work closely with is penetration testing, which is a specialized form of highly skilled testing focused on finding security vulnerabilities, exploits, that sort of thing. And I mean, well, that's widely available, right? I mean, there are dozens of companies in the City of London that provide those kinds of services. It's really out there. And this is kind of the part that I wanted to characterize as human effort on the left side of this slide. And then over here, we have automation. And so that's actually what I spend a lot of my time on, this stuff here. And so we have things like, and again, most of this stuff is not going to be particularly new over here, but I just wanted to go through this list anyhow. Which is, we have black box testing, and so fuzzing is, of course, the poster child for that. And fuzzing is not a new topic, is it? I mean, you can go and find old papers from the 80s, before they had PDF, right? I mean, like those papers you have to like find scanned by somebody, but there are papers from the 80s that talk about, finding bugs in Unix utilities, yeah, by using fuzzing. And so, well, the situation has only improved since then, in that we actually have fairly effective fuzzing tools, like, what is it? AFL, for example, is one of the very popular fuzzing tools, and in fact, it's applied to real software. You can go and find tons of bug reports. For example, I work on browser security. Tons of browser bugs are found through fuzzing. But of course, these days, this is, put in a cluster, dozens or hundreds of machines, running fuzzers every single day, in lockstep and coordination and so on and so forth. But in aggregate, this is actually a fairly effective way to find bugs. The next topic here is white box fuzzing or symbolic execution. Do you know what symbolic execution is? Show of hands. No? Oh, you're missing out. How come? It's so exciting. All right, I'll tell you what it is in just a few slides. Let's kind of go a little bit faster. And of course, all this other stuff, all this other stuff that I tend to work on, such as static analysis, runtime analysis, that sort of thing. Most of it is based on automation. All right. So next slide here. Yes. And so I wanted to start with a picture that comes from last year's conference, from a talk by one of the organizers here. So this picture here. And this characterizes, this is something from the World Quality Report 2015-2016. It says here in really tiny letters, so I tend to believe it. But it says here that, well, if you look at the practice of testing, yes, you'll find that 80% is done manually, and then 20% is automated, and then here you have UI automation as well as API. Okay. As I said before several times now, my focus is really primarily on automation, right, or automated testing. But I don't want to be so dogmatic here. I mean, my position is that, well, these things work well, or they work best, perhaps, when they're combined in proper proportions. Now, if you look at this picture, I would argue this is probably not the right mix. I think, manual testing perhaps should be a little bit less than 80%. I think it should be a different balance between those two. But, well, let's see how it goes. So I already talked about the case of mobile app testing. So there is a company in, I think, Germany, if memory serves, called Applause. This is one of many such companies, by the way. I'm not here to promote them, but I just saw them at a conference, a few days ago, so I remember the name. So this is what I described to you just a few minutes ago. Essentially, you have a binary for a mobile app. You give it to them. They have a bunch of testers on retainer. The effort is somehow coordinated within the company so that they don't presumably waste their time doing the same kind of activity, right? All of them. And then they give you a report, and some of these companies will give you a report within an hour. Sometimes it's a day, sometimes it's a week, and so forth, depending on the complexity of the application and, of course, how much you're willing to pay. Yeah. So this, I would argue, is sort of within this ballpark, right? It's mostly manual testing with a little bit of automation, and automation perhaps takes care of things like, well, how do we avoid wasted effort? Right? So how do we make sure that these testers, suppose we have 10 testers and we have one poor application, like what do we do? How do we make sure that not all of them do exactly the same thing? Any thoughts? No? Because, they'll probably just follow the same exact path through the front door of the application, right? So in a certain sense, well, they'll do exactly what the users will do, which is maybe not a terrible thing, is it? But, in a different sense, well, they're probably wasting their time, and they're wasting your money as well in the process, right? So, like, how could we do something different, right? So, I don't know. Well, so suppose this app has 5 different screens. It's a really small app, right? So maybe figuring out a way to have them start at those different screens and not everybody starting with the front door, so to speak, of the application, maybe that's a good thing. How to do that requires some automation, right? We don't quite know how to do that in a general sense. We certainly wouldn't know how to do that if this application requires some sort of a login. How to jump right beyond this login screen seems to be a problem. It's not an unsurmountable problem, though, but what I'm trying to allude to here is that this is an example where manual testing and automation could sort of meet each other in some sort of a, happy synergy, say. Synergy, that's a wonderful word from the 90s, I guess, or something. All right. Yes, and again, so it's tempting to say, well, manual testing versus automation, right? So how did they compare? And it's sort of difficult to answer this this question comprehensively. And so it sort of also depends on your goal, right? So, some of the goals are listed here. So, for example, some operational goals are, well, let's make sure that the application doesn't crash. What does it mean? Well, it doesn't crash ever. Sounds like a nice property to have, but probably pretty difficult, yeah? Under all inputs. Or say it doesn't crash when you start it, which seems like a pretty low bar, but you'd be surprised by how many, for example, mobile apps in any app store fail that bar when they go through whatever version 53 and they release it late at night, and then strange things tend to happen. Yeah? Okay. And then, of course, there are sort of more development style, more sort of comprehensive, in-depth goals. For example, making sure that the coverage is high, or that the coverage is 100%. And what does it even mean to have? What is coverage even, right? So typically, when we talk about things like unit testing and test suites, right? We talk about coverage, and we typically talk about things like basic block coverage, or line coverage, or function coverage, or branch coverage, or path coverage. Yes, so there's like 5 different options now. Do those things sound familiar to you? Some of you, yes. There are some nods. Okay, that's good. So that's good. But of course, then the question is, well, which notion of coverage do you pick, perhaps? For example, I love path coverage, but it's very difficult to attain high levels of path coverage, isn't it? So, I don't know. Any guesses as to what some of the averages might be for path coverage for an application that's in wide use. Let's take, I don't know, what's a good application? Chrome, let's take Google Chrome. Let's criticize them. What do you think the path coverage is for the test suites that they release with the, or that are in the repository one can run? 5%. 5%. 17. Anybody?
49.
Thank you. You win a prize for the most optimistic, sort of test coverage participant here. I'd say like 30% would be probably pretty realistic, right? I mean, it's very difficult to get high numbers, high levels of path coverage. It's just really, really tough. Okay, so I'm being told that I should speed up. Do we have a presenter after me though? Have they been found? Huh?
Yeah, I was supposed to speak at 10, but I was sitting in.
What happened to you?
I was listening to the other guy. I lost track of time.
Well, you snooze, you lose. I mean, I'm now here. Okay, fine. I'll finish. All right. So, yeah, you're welcome. So the point is that we want to take multiple techniques here, some manual, some automatic, and figure out a way, perhaps, to combine them in a way that makes, the outcome, so to speak, right, the sum bigger than the, than the parts that go into it. Yes, so that's kind of the idea, right? So we basically take, these diverse techniques, testing techniques here, figure out how to combine them in interesting ways. And so some of the fundamental challenges here with this approach is that, well, how do we avoid the overlap? As I alluded to just a few minutes ago, right? It's really, tempting to basically do the same thing. If you have 10 testers, you'll give them the same app. Most of the time, they'll basically waste doing exactly the same thing. So how do I avoid this, overlap here in the middle? How do you basically focus on the differences? So how do we basically figure out a way how to hit something over here that's not covered by these efforts? More specifically, so for instance, in an effort to get 100% pass coverage, which is a wonderful goal that is genuinely not attainable in practice, but aiming toward that, if there is a specific path within the application, can we figure out a way to hit it through the use of symbolic execution, for example? I wonder if I should even talk about that or I should skip that. But so here's a paper I wanted to mention. This came out just a few months ago. So these guys study 4 large open source Java projects. And what they discover is that there are significant differences between what is covered or what is developer written tests represent, and what is actually hit in the field. And they measure those differences and they highlight some of the, some of the ways in which those two are at odds. But this is, again, sort of a common theme, right? You use different approaches, you get different outcomes. I'm being told that I should hurry up because I want to get to the end of this. So how do we coordinate our testing efforts, right? And so as I keep saying, essentially, multiple techniques or multiple people involved in this effort are really likely to sort of basically stay here in the middle. They will basically cover the same execution path time and time again, and that's not really all that exciting. So this middle part is really quite boring because I think you'll flush out those bugs, right? So this stuff over here that's encountered occasionally perhaps, we don't even know precisely how to cover that. We don't have, a strategy, although sometimes techniques like fuzzing, for example, will get us to something over here. And then when we have something that is seen once in a blue moon, how do we even get there, right? So one of the approaches that I mentioned here is that, basically maybe targeted symbolic execution is one of the ways to do that. And so basically this is where this idea of gap testing comes in. So we want to avoid repeated and wasteful work. And we want to find clever ways to hit methods or statements or basic blocks or paths that are not covered by other strategies and methods. So I wanted to, can I have 3 minutes of your time?
You can have all the minutes you like.
Oh, you're so generous. Okay, so then I'll,
6 minutes.
Not my time.
okay, sounds good. All right, so I want to talk about two specific projects that I've worked on, that we built, that I think are relevant to this. So the first one is crowd-based UI testing with a goal of 100% of what we call screen coverage. I'll explain what it is in a few minutes. So the other one is what's called targeted symbolic execution. The goal here is to hit interesting path within the code. I think I have 1 or 2 slides on each. So the first one is for UI testing. So the setting here is that we have Android apps. We want to have what I call 100% UI coverage. And so the way to think about it is that, well, we can take an app and decompose it into a bunch of screens, right? And it's actually, I mean, if you look at the resources of an app, you'll find it right there. So a typical app may have, I don't know, 5 to 10 screens, yes? And so clearly one of the goals is to make sure that within the process of testing, testers, have seen all of those screens because, well, why else would you put them in the applications in that sense, right? Okay. Seems like a pretty easy goal, isn't it, right? Much easier than, say, path coverage, which I claimed was almost impossible to get to 100% level before. This seems quite attainable, isn't it? So, so how do we do this properly, right? So suppose we have a bunch of testers on retainer. We pay them small amounts of money. They're not so demanding, and they don't really do so much work. Maybe it takes, I don't know, 10 minutes or 20 minutes of their time to do this. Seems like a pretty affordable situation. We should be able to build a system. But fundamentally, we see all the challenges that I talked about before, which is, well, we just unleash them, we give them the binary, and they all do the same thing, and then they all go home. And so maybe out of the 10 screens that I want to cover, only 6 will be covered. That's not quite enough, right? So how do we figure out to direct their efforts? So we built a system where we basically, and this is, oh yeah, this works, good. So we start with an application that might look like this. So it will have these screens over here. So this is one of them, this is another one, this is yet another one, and so forth. We will eliminate, we'll modify the application as this testing process continues, so that things that we already have seen through this process of testing, we will not cover. So we'll block, ways within the UI. So for example, what we'll do is we'll take, for example, these links over here, and we'll darken them out or just completely eliminate them from the UI. In an effort to guide testers toward parts of the applications that we yet haven't seen covered. Does this make sense? Avoid wasted effort and guide them to parts of the application that we haven't seen before. So we'll continuously modify this application underneath them, so to speak, with this goal. I mean, in practice, the way it works is that, well, we have the new tester from the pool, they come in, they have a modified version of the application. They have this bastardized version of the application that has these modifications designed effectively for them with a goal to increase coverage in aggregate, right? Because ultimately what we care about is aggregate coverage from the pool of testers for this app. So with this approach, we actually are able to get to 100% screen coverage in most practical cases. There are challenges, though, that relate to things I mentioned before, such as login screens and, frankly, functionality that almost none of the testers can find. Turns out that developers design things that are really tricky for testers to find, no matter how hard they try. I remember these heartbreaking interactions with some of the testers where they say, well, I've tried, and there's nothing I can do to sort of explore other parts of this application. So it's not without certain problems, but it certainly is a very promising approach here. Yeah, so this is disabling parts of the UI in an effort to basically guide testers further. And the last thing I wanted to talk about is this, which is guiding symbolic execution. So symbolic execution is a wonderful thing. So it's basically a way to systematically explore a piece of software. So it's a very specialized way to run a program which involves figuring out ways how to explore control flow in a systematic manner to go through all the branches. So basically what you do is you create what's called path conditionals. You solve them using a theorem prover, and then you create inputs, and the goal of those inputs is to go further and further into the program. This is an approach that's been used for many years. For example, at Microsoft, it's used at a very large scale to find all sorts of bugs in Microsoft Office by applying this to file formats and things of that nature. And it's used in other contexts as well for all sorts of, say, open source software and so forth. One of the challenges here is that this is an exponential technique. It doesn't scale so well. You can run this for hours and hours and days and months and still not quite find enough. And so one of the approaches we've seen done, applied better or applied in recent years is what's called targeted symbolic execution, where you not only are you just kind of blindly going through the application in an effort to explore more and more paths, which is a fine goal, but one that's very difficult to scale. You basically have a clear target, which is to say a place within the program, perhaps an API call, or a module, or a function, or something of that nature, and you basically bias this exploration in a manner that is more likely to hit that part of the code. And this is one of the techniques you can use to basically, as I said before, cover those gaps. Yeah? You have something in your testing strategy that hasn't yet been covered. This is one of the secret tools you can use to figure out ways to hit exactly that without hopefully wasting too much time. So the ultimate vision here is that we have a portfolio of testing strategies that can be invoked on demand, applied to a given piece of code. We want to deploy them together to improve the ultimate outcome, such as coverage or some notion of coverage. Sometimes manual testing is the right approach. I don't have much against it. Sometimes automation is the right thing to do. We've seen some examples of testing strategies that I think are complementary to each other. But figuring out ways, clever and effective ways to combine them for given settings, that's something that requires further thinking and further work. So I'll stop here. If you have questions, I'm happy to take a couple. Yeah.
You mentioned modifying the application to reach better coverage.
Yep.
Is it a risk if you modify the application that you actually change the thing you're testing, you might miss something or affect the result of testing by this?
Of course. Every time you modify something, there's always a risk, right? I mean, that's basically comes with the territory. Nothing new there. Yeah.
And is there a good way how to modify this and avoid the risk or minimize the risk?
If you find something, you can always rerun it on the unmodified version of the application, right? Remember that. So we have that advantage. But in the process of looking for things, we're willing to cut a lot of corners, right? So.
Sure. Thanks.
How good the methods you describe are in reproduce the same error? Because as you know, for developers is often important not just get some signal what error exists, but have stable way to reproduce this error.
So specifically symbolic execution, which is what I had in the last slide here, is excellent at creating repros, right? You basically have the entire input that you can feed into the application and basically observe the failure. And you can stuff it into a debugger and figure out what's going on there. There are issues with minimizing the input, so it's actually debuggable. We can talk about that. There are issues of non-determinism as well. Unfortunately, in any large piece of software, you'll have that. But modular that, something like this gives you really nice, compact bug reports, which is why developers love this as opposed to many other things.
Another question, with your approaches, you try to hit this 100% target, which is, of course, very good in the ideal world, but in real life, the closer you get to these numbers, the more effort you spend, and in my experience, I have some customers which says we don't need all permutation. You try to enter in our application. Our customer never do it, so please stop it. Don't waste the time. So, how do you think from the business perspective? Does it make sense to try to get this 100% coverage?
Certainly not always. Much of the time you'd watch the curve, right? As you spend more effort and time, you watch the, say, coverage numbers, you find the knee of the curve, you stop it there, right? So I'm mostly with you. It really depends on, I mean, in a practical setting, that's what one would do oftentimes. If one really wants to have better guarantees, and one is willing to pay for that, then perhaps waiting longer is viable, especially for a situation where you can actually hit that 100%, which is sort of unique to this smallish mobile app world. For an application that's tens of millions of lines of code, well, not so much.
And do you have some techniques which help to see what this coverage is devolved, which effort start raise exponentially is already reached, and it's not doesn't make sense to continue to widen the test scenarios and the coverage. Do you work in this direction?
I mean, typically things are just highly instrumented, right? I mean, basically you have a heavily instrumented piece of software, you can monitor just about anything about it, right? And then you have some orchestration tool that runs these things in a cluster, collects this data, blah, blah, blah. We can talk about these things, but even simple things like AFL these days do this for you. So it's fairly commonplace. It's not so unique. I mean, you can find these things in open source.
Thank you.
Yep. Use the mic.
You mentioned about developers writing tests. I mean, I have been in a situation wherein I was a developer as well and tester as well and writing automation and doing manual testing. Do you think is when testing is most of finding scenarios, paths, and other things, and to break the code, developers would do justice in writing automation test case? They may write test cases faster, probably because they have been doing that all their life, but is it effective thing in a long run?
What is effective in the long run, Bill?
Developers writing automation test cases, or developer testing their code.
Well, yeah, this is sort of a bit of a long discussion, right? So it depends on the philosophy of the organization. Many organizations demand that be done. Many organizations demand, test-driven development and so forth. We can talk about the effectiveness of that. One of the things that comes into play, though, is that it's easy to be blindsided when the same person writes the code as well as the test case. They're not really in this adversarial mindset. They're basically like, well, I've logically designed this thing to support, say, these inputs, and I'll test that to make sure that those things are supported. Whereas that's not what you want. You sort of want somebody who thinks outside the box, perhaps a tester or someone else. That's what, for example, happens in penetration testing scenarios, right? Somebody from the outside comes in, and their goal is to break things. And so a lot more of that is needed for effective kind of practice. When somebody is just doing that as part of the job, so to speak, it's really easy to get accustomed to get a bit more complacent, I think, than is safe. Yeah. Thanks.